want to talk about evolution, and you don't believe there's a God too.
No,
Do you believe that the universe is eternal?
I have no idea.
Oh, just no idea. Okay.
Well,
All right.
nobody does.
So maybe you can strengthen my knowledge of evolution because I only know Darwinism's argument that complex organisms arise from simple organisms, and that's what I'm going to try to disprove to prove inconsistency with evolutionary theory and hope that it applies to the whole. So,
Interesting.
yes. So, from what I've read, and I have a source for that too, it states, remember that evolutionists teach that everything is constantly evolving into a higher and more complex order. In other words, they believe things continue to get better and better instead of worse and worse. If water being heated on a stove is at 150 degrees Fahrenheit and the burner is turned off, the temperature will drop instead of rise. It will move towards colder rather than hotter. If a ball is placed on a hill, it will always roll downhill and not uphill. Energy used to perform any particular task changes from usable energy to unusable in performing that task. It will always go from a higher energy level to a lower energy level, where less and less energy is available for use when applied to the universe. For use. When applied to the universe, the second law of thermodynamics, and I'm almost done, indicates that the universe is winding down, moving towards disorder or entropy, not winding up, or moving towards more perfect order and structure. In short, the universe is winding down, and evolutionary theory is inconsistent because it states that things get better, but entropy states that things get worse, and entropy is a part of a law of second law of thermodynamics. So, what would you say to that?
Um, it massively. How would I how would I put that? You it leaves out something extremely important. So the second law of thermodynamics describes a closed system. So a closed system is one where energy is no
In an
longer
isolated system.
where energy is no longer moving into the system. So yes, when you turn the burner off, then the water cools down until it reaches thermal equilibrium with its environment, right? So the
Okay.
capacity for that steam, like you can heat water up to uh, create steam to power a machine, for example. But when you take away that heat source, like if your car runs out of gas, it won't continue to move. I mean, it'll coast until it simply runs out of inertia and then becomes at rest with the environment, right?
Yeah.
But so does that mean that life or evolution violates this? No, because the planet Earth is not a closed system at all.
The universe is.
Um, the yes, but life on Earth is not. Okay, so okay, we'll start small and then go big for this one.
Yeah.
Although talking about the universe is going to be kind of weird. Um,
Yeah.
where does Earth get its energy from?
Um, the sun.
Yeah, the sun, right? So there's a constant supply of energy being delivered to the Earth from the sun. So there's nothing about like entropy can continue to increase on our planet, but there's a never ending stream of extremely low entropy energy in the form of light from the sun coming here. That's so like producers, photosynthesizers for the most part, continue to produce organic tissue by borrowing external energy. And so the whole
So
process
you're saying the Earth is getting
works.
external energy from the sun.
Yes.
The second law of thermodynamics, entropy, uh, is talking about the whole universe, and its unusable energy is increasing as entropy increases
Yeah,
in an
yeah,
isolated
I
system
agree that
of the
the
universe.
universe is reaching uh is getting to that point, but
Yep.
you know, the sun is still like when you take the water off the burner, it still is hot. It still has usable energy there.
It's
Now that
decreasing.
energy decreases pretty rapidly for a pot of boiling water.
Yes.
The sun is losing energy.
Yes.
It's losing mass, but the sun will be going for billions of years. I agree
Yeah.
that it won't go on forever, but like there's really no problem here because
Okay.
like your statement is kind of fallacious in one sense because it assumes that there's no energy arriving to Earth, and that's not true. But in the other sense, where it's like literally true, but completely misunderstands the scale at which things are occurring.
Well, I just thought that I was hoping that maybe you can educate me or whatever, but I just felt like from what I'm reading, it is inconsistent because Darwinism, Darwin is saying that things get better, but that's just totally untrue with the law of thermodynamics. Things get worse.
No,
It doesn't matter how long it takes, things get worse. So that's just very inconsistent.
no, it's not inconsistent at all.
It's saying that at the scale of what things were getting better from, it's getting better, but that's not possible according to the second law of thermodynamics.
Okay, if that's true, then life just simply can't even exist
How so?
because living organisms have to take in energy and resources from the environment. Whether or not
No, they don't.
evolution happens, organisms still have to live, which means we have to take in matter and energy from the environment. And then as you interact with the environment, you increase the rate at which entropy occurs. So
Yes,
even if evolution didn't happen, life would like if this argument like if we follow this argument, forget evolution, life as a process can't occur.
that's a point. That's the point. In science, it can't occur.
Yeah, but
Though
you're
there's
arguing
leaves
against
one last
evolution.
conclusion.
You're arguing against evolution, but life in general can't
That's the
happen
point.
if okay, so then
I
you don't
believe
think that life
evolution.
is possible.
No, I believe it is possible through God.
How?
Through God. That's the only other. That's the only other thing. It's literally inconsistent with law of thermodynamics. Evolution is.
So
So the
then
only other
okay,
way,
here that doesn't make any sense because life does exist and we have no evidence of a god intervening here.
basically, with evolution being disproved, and
No,
with
no,
the
no, no,
Earth,
no. You've
Earth,
disproven life in general.
no, not if there's a God.
Yes.
And scientifically, I did, but not if
No,
there's a God.
that's not scientific at all.
How is it not scientific? So tell
We
me
went
if
over this.
so the law of so entropy is
Yep.
stating that things get worse.
I don't know what
Evolution is
worse
saying
means, but things maximize their entropy over systems maximize their entropy over time.
things lose quality, they decay according to entropy. They lose usable energy, they're decaying, they're deteriorating over gradually over time. Evolution is saying things get better, organisms get better. That's impossible at the
Oh my
uh,
goodness, no, it is not impossible. If a
when
bridge is
compared.
if a bridge is rusty, then what we can do is we can expend energy to fix the bridge. Now
We can.
we have put the bridge in a better place, but we have used energy in order to do that, right? So we have still put energy into the system and it's still been lost into the environment and entropy has still increased. Not
Hmm.
necessarily yes, Blitz, I do want you to hop on. Not
Yes, I want
necessarily
Blitz to hop on too.
not necessarily from the perspective of the bridge, but entropy has still increased.
Can you add Blitz right now? Because he can explain this way better than me. He knows physics. I
Yeah,
just wanted
I
to.
know he does. I he has to go switch to his other account, but yeah, he'll be on here soon. So
Perfect. So yeah, basically what my only argument would be like, um, it doesn't match up with the law. Is what it appears to be. Unless you can tell me how things getting better means things are getting worse, then
you could still cook rice in a pot of water after you turn the heat off. There is still usable energy for that process to take place, and like Earth, like the fact that things can occur on Earth even though entropy overall is increasing is the same kind of idea. So,
Blitz, what do you have to
Blitz,
say
go
about
ahead.
this? Because I need to hear a little
Both
bit.
of you
Like,
guys are misunderstanding the second law of thermodynamics.
Oh no.
okay,
The second law of thermodynamics says that in a closed system, entropy never decreases. That's it. That's all it says.
entropy never decreases,
Yes, that's all.
but a closed system is the universe.
Well, whether you can consider the universe as a closed system is a different story. Certainly, Earth is not a closed system.
But the universe. So where did the organisms come from? Did it come from the Earth or did it come from the universe?
Presumably, it came from the Earth.
How so?
I mean, it's not well understood, but the idea is that complex chemical arrangements can occur spontaneously with sufficient energy input.
That still doesn't explain, like, to me. You're gonna have to use simpler terms because you're a physicist. I'm a pre-med student, so you're gonna have to. I don't know much about physics, basically. So,
Right. So the
but
idea is that, and so there's two problems here. One, entropy is not the same thing as decay. It's not the same thing as disorder. Entropy is just a measure of how likely a state is. So let me back up. So let's say that you have like a bunch of dice, right? You have like 100 dice in a bag.
mhm.
Now, let's say the only state that you care about is the count of the total number on all of the dice when you dump them out, right? So it doesn't matter what each individual die reads. All you care about is what the sum is between all of them. So for example, if we only had 2, then the most likely state that you would get is the number 7. If you roll 2 dice, the most likely number that you get is 7 when you add them up, right? This is how craps works. So actually, let's just work with 2 dice. So you have 2 dice in your bag.
Yeah,
The most
that was
likely
way too many.
state is right. The most likely state is 7, and that's because 7 corresponds with the highest number of microstates, highest number of possible arrangements of the 2 dice. You have 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, 6 and 1, right?
Could you just say, like, could you use? Oh, never mind. Keep going. Never mind. I'm starting to
Right.
understand.
So the more possible ways that you can get a desired outcome, the more likely it is. And that's what we mean when we say a system or a state has high entropy. The more ways, like the individual pieces of your system can arrange themselves to give you a state that you're interested in, the more entropy that state has. So all we're saying is that statistically speaking, if you shake up a bag of 100 dice, the chances of you getting 3,500, I guess, would be the mean, roughly. The chances of you getting a total of around 3,500 is much, much higher. And so by shaking up the dice, you're increasing, let's say the dice all started out by 1s, right? And then you put them all in the bag and shake them up. Now, the chances of you getting not all 1s, but instead a total of 3,500 is much, much higher. So you're increasing the entropy of the system. You're increasing go ahead.
How come, from what I've learned and with the sources I've gathered, allaboutScience.com, rcg.org, it all states that entropy is a measure of the decrease in usable energy, and my professors do.
So you can talk about entropy as a decrease in something called free energy.
It also talks about disorder and order.
In particular, Gibbs free energy or Helmholtz free energy, which are specific notions.
I've heard about that, and I've never been good at calculating that. So, what is the significance of that
I don't
the
like
overall
thinking
term?
of it. I don't like thinking of it that way. Basically, the idea is that Helmholtz free energy, at least, because Gibbs free energy is for chemical processes. Helmholtz free energy is basically energy that is available to do work. So when we talk about work, we're talking about like expanding a gas.
Yeah. Energy is needed for work, for sure.
Helmholtz free energy is the available energy to do work.
Okay, what's left?
So this just says that the Helmholtz free energy decreases.
What's
And this
left
makes sense because
decreases.
the energy available that can't do work decreases. But again, this is in a
What?
closed system.
How does that make any sense? It's
So
from what the
because
definitions are telling
work
me.
gets done. When work gets done, you have less energy to do work.
But how does that make any sense? Because if entropy is a measure of the decrease in usable energy, how can it be the measure of the decrease in the decrease of the usable energy?
No.
So basically, the measure of the decrease in what's left, which has already been decreased.
No. So I think you're just misunderstanding. So entropy is basically the negative change. Well, it's not quite the negative change. It's related to the negative change in the Helmholtz free energy. So if Helmholtz free energy goes down, then the entropy goes up.
Okay. That just means that a measure of decrease in usable energy. So the decrease in usable energy goes up, basically.
No. The amount of usable energy goes down
Over time in an isolated system.
Yes. In a closed system. Yes, precisely. But the Earth is in a closed system, so we don't have to worry about it.
Yeah.
But how does that explain outside of the Earth? Like, how does that explain? How does that explain evolution? How does that not make it contradict or be inconsistent with evolution?
So evolution takes place on Earth. We agree on that. If it takes place at all, it takes place on Earth.
Okay.
Right. The Earth isn't a closed system, so the amount of available energy to do work doesn't decrease. It can increase because there's energy coming in from the sun.
Yeah.
So then, let me see. So basically, it's getting energy, so it doesn't. Well, this is what I'm trying to say. Since entropy is the decrease in usable energy, and the universe is an isolated system, that means everything within the universe is decreasing in usable energy, which is the sun.
For what it's worth, the notion that the universe is a closed system is not one that's agreed upon.
Oh, are you sure?
Yes, because the universe, as far as we can tell, the universe doesn't conserve energy.
That doesn't matter. It's not being acted upon. It doesn't have anything surrounding.
No.
Let me go to the definition.
When we talk about a closed system, we're talking about a system that conserves energy and conserves momentum. But if the universe doesn't conserve energy, then we might have to throw that notion out.
Basically, the universe is an isolated system, which
what part of the isolated system is the part that matters for the sake of thermodynamics? And the part that matters is the energy conservation. But if the universe doesn't conserve energy, then it doesn't matter.
Yeah. This is also very irrelevant to whether or not evolution takes place.
No, it's very relevant because
it's not, because what you're arguing is that evolution can't take place because organisms cannot continue to gain complexity if the rule is energy is lost and entropy increases. But that, as a whole, yes, energy does decrease, but that doesn't mean that life here on this tiny little speck can't occur. That statement doesn't mean that every single thing everywhere must always go towards disorder. That's not the case. Like when I talked about fixing the bridge, when you fix the bridge, you create order within that structure, but you have used energy, and so you've maximized entropy in the aggregate overall in the system. And life is able to happen, and evolution is able to happen because the organisms take in a stream of energy that's coming towards them, and they use that energy in order to do specific processes.
Supposedly, but it's just not consistent.
Supposedly? What do you mean supposedly?
It's not consistent. It's still not consistent.
Yes, it is
Y'all
consistent.
are saying the Earth. Y'all are saying, well, hold on. Y'all are saying the Earth is not a closed system.
Correct.
which means
Entropy
that
applies to the universe. Entropy applies to
Earth
the
is not the
so
universe.
universe.
if we're
And the
asking about
universe is a.
evolution,
I wish I could finish.
if we're asking about evolution, entropy can decrease on Earth. That's just true. We agree on this, right? Because it's not a closed system, entropy can decrease on Earth. And that's
No, I
the only thing we
disagree.
need in order for evolution to happen.
I disagree with the sources I have. It's saying
Wait,
way different.
what sources
If that's
say that
true,
the
then the
entropy
temperature on
I
Earth
gave
could
him.
never increase anywhere
I
at
wasn't
any
here.
point. But it does, obviously.
The Earth. Okay, first, what y'all say about the
Like,
universe
forget
being
about
an
life.
isolated
If
system?
you're saying this, then nothing can ever, like, we cannot
That's
have.
the point. That's the
What?
point. That is the point.
What's the point?
That since this contradicts each other, the point I'm trying to make, if this is true, unless Blitz persuades me after I'm done explaining and after he's done explaining that what I'm saying is not true, the point is that God exists and that evolution is not
That does
true.
not necessarily follow at all.
And my argument that I'm proposing is that entropy applies to the universe. The universe is an isolated system by definition, and that if you look at entropy and the universe and it increasing in the universe, which means every single thing in the universe is increasing
No.
in entropy.
No, this is a misunderstanding. That's where you're going wrong. I think that's the thing you're misunderstanding. Just because
How
a whole
is-
like, let's say my house is a closed system, right? Let's just
Yeah.
say that.
Yeah.
Just because the total entropy of my house is increasing, doesn't mean that I can't have that the entropy of my bedroom decreases. So long as when the entropy of my bedroom decreases, the entropy of something else in my house, like my kitchen, increases more, that's still fine. You can have isolated pockets, not isolated. You can have separate pieces of a thing have entropy decreasing in an isolated system while the whole system has entropy increasing. That's the point. Just because the universe's entropy is increasing, which we can't even agree that it necessarily is, but let's assume for a moment that it is. That doesn't mean that the entropy increases everywhere in the universe. It just means that it increases on as a whole, like total in the universe. You just add up the change in entropy everywhere, and you get something that's increasing.
Okay, but even if entropy increases somewhere over here, but doesn't increase somewhere over there in a non-closed system of the Earth, what you're saying, how does that prove that it does not conflict with evolution? Saying that
the point
simple
is
organisms.
The point is that the entropy here can decrease, so long as the entropy somewhere else increases more. And that's totally allowed by the second law.
What says that again? What states that is possible?
What do you mean, what states? That's the definition of entropy. Entropy is an additive.
No, the definition of entropy is the measure of decrease in physical
entropy
energy in the universe.
Entropy is an additive state variable, which means that entropy adds up between different regions. And if all you're saying is that the entropy of a closed system of the universe increases, that doesn't say anything about the entropy of the pieces. All that says is that the entropy of the whole system increases. Well, and in particular, because entropy is additive, if you have a decrease in entropy somewhere else, all you need is a countering increase in entropy by more somewhere else.
Even with that, it still is inconsistent with evolution, because evolution is saying every single simple organism will become complex. Every single one. So even if you say that, it's still
if
not
the organisms
consistent.
themselves were the only things in the universe that existed, then yes, it would be inconsistent.
Yeah, we're just talking about Earth as a whole. The entropy of Earth and everything on it.
Yeah, we're talking about evolution first. I'm talking about evolution.
Right. The entropy of Earth.
Yeah, organisms can increase their complexity by using matter and energy from the external environment to do it. They take energy and resources from the environment and use it to lower their entropy. Meanwhile, entropy in the environment increases. It's conserved in that way.
Well, if the entropy of the universe is always increasing, then the entropy of the sun is always increasing, putting energy onto the Earth, which means the entropy of the Earth is increasing.
That's not true.
How does that not make?
Yeah, the sun's getting hotter over time.
No,
I mean,
it's not.
the sun's entropy is increasing, by the way, but just because the Earth's entropy is increasing, or just because the universe's entropy is increasing, that doesn't mean every individual part has an increasing entropy.
But it still means it's inconsistent with evolution.
It's not.
No.
Because
So if the universe's entropy is increasing, that
Yeah.
like there is nothing that implies that the entropy of Earth is increasing.
okay, what I'm saying is that
Do we agree on
if
that? Or are you saying that's inconsistent with
no,
what you've seen?
no, what I'm trying to use is what you're giving the definition you're giving is what you're saying that it can decrease somewhere on Earth and then increase somewhere
No, it can
else.
decrease somewhere in the universe.
What about on Earth? It's always decreasing.
The Earth isn't a closed system, so we don't even have to worry about it. It can
But
always be it can be the case that it's always decreasing on Earth, and that
that's
would be fine.
impossible.
Why?
Because using that logic, the entropy as entropy increases on the sun, that means the sun could possibly come into non-existence due to having no more usable energy.
The
So
sun
how would
will
the Earth
run out of
still
energy.
be?
Yes.
How
It
would
will.
the
It
Earth?
just
it
takes
will.
extremely long time.
It's going to.
It's going to what?
It's going to come into non-existence because it runs out of usable energy. That's going to happen.
I know, and what I'm saying with that is, if that happens, that means the Earth will become non-existent, which means
Well,
you
it
can
won't
say
become
that
non-existent. Hold on. Things don't just stop existing. They just stop changing states.
basically they
So
would
they'll just
stop
become
moving
dead.
because there will be no energy for work to be done.
Yeah, and that will happen in some point in the
Yeah,
distant future.
if that happens for the sun and that happens because of it happening for the sun, it happens to the Earth, and that means entropy is always increasing on the Earth.
No. So
What?
the reason, okay, so the sun is going to run out of fuel in 5 billion years or so. When it does that, it will not be well. It'll still be hot. So in a trillion and a half years, when the sun has both run out of fuel and just cooled down just by radiating off heat, the Earth will still possibly exist as just like a dead space rock. At that point in time, the Earth will effectively be a closed system because there won't be any energy sources by which the Earth can get energy.
Okay, so basically,
When that
what
happens,
happens?
but
I have a
that
question.
doesn't have any. But all that's saying is that because the sun is no longer providing energy, that just means that the Earth is now effectively a closed system because its source of energy is no longer there. This doesn't have anything to do with entropy, though. This just has to do with whether a system is closed or not.
Basically, right now, like we know that the sun entropy will cause it to come into non-existence and
Well, it
not be
doesn't stop
using.
existing.
Well, it doesn't have any usable energy, and with knowing that affects
Yeah,
the
but in the
Earth.
meantime, it gives off energy and things can happen.
That does.
Like
Here's
if
the
you
point I'm
take,
trying to make.
I already did this. If I took some boiling water and I removed it from its heat source and I put some instant ramen in there, would that water be able to cook the ramen? Yes.
Yes.
Yeah, it would not be able to continue cooking ramen for eternity, but there are things that could take place between me taking the water off the burner and the eventual heat death of the universe.
Whenever you take the water off, its usable energy decreases,
Yeah,
and then it
and
decreases
that
even more
energy
when you
can,
put the
but that
ramen in
energy
there.
can still be used
Hold
to
on,
do
its
things.
energy. Its usable energy doesn't
It can
decrease.
still
It
be.
stops increasing.
It's as if you're pretending the usable energy instantaneously transforms or becomes zero, and that's not the case.
How is the usable energy not increasing for an isolated system in this scenario, the boiling pot on the ramen? How is it not increasing for that pot, and then eventually
What?
increasing for the ramen whenever the pot is out of heat? Blitz.
Sorry, can you repeat that question
That
again?
didn't. Yeah, that was.
I
How
didn't
is
follow.
entropy not increasing for that boiling pot as a isolated system on the ramen, and then it not
What do you mean
in,
as an isolated system on the ramen?
The entropy
meaning
is increasing. You're saying,
So,
how is it
so
not
if it
increasing?
helps,
It is increasing.
Meaning,
if it helps, we can treat the Earth and the Sun together as a closed system.
I
It's
just
not
want this
exactly close,
question to
but
be
it's pretty
answered.
close.
I just want
I just don't
to
know what
make
your
sense of
question is.
this.
Sorry.
I just want to make sense of this logic. Y'all are saying that usable energy is not decreasing with that hot pot of water.
It is decreasing. That's why I said the pot will not be able to cook ramen for eternity, but there is
Yeah.
a period of time in which it can do that.
Okay,
Yeah.
but
You know
it's still
that's
it's
true.
still it still decreases. Is my point.
Once you take it off the pot, yes, it will
Yes.
decrease
Okay,
because it's
okay,
giving
okay,
off some
okay.
energy to the air.
More to that.
Yes, but
After
things
that,
can happen in that time.
well, hold on. After that usable energy decreases for that pot, the usable energy for the ramen decreases once it's cooked. So the universe is so we can conclude that the universe's entropy is increasing everywhere, including the Earth.
But no, that's not true
On
though.
average,
How does that not make
yes.
sense?
So you're
It's
drawing causation from correlation. Yes, once you
that's not
cook ramen,
correlation.
it
That's
has less usable.
that's a law to happen. That's
No,
what's
it's
going
not a
to
law.
happen. Second law of thermodynamics.
No, you're not describing the second law of thermodynamics.
That entropy is the central idea
So
of second law of
do
thermodynamics.
we agree that if I hand so let's go back to talking about dice because dice is
Okay.
a really easy
Dice
really
is
easy
tough.
thing to understand.
Dice is tough. You're gonna have to come up with an explanation.
I want to say just one thing really quick. What you're confusing the idea that entropy overall increases with the claim that entropy everywhere for everything always increases. And that's not necessarily true at all.
It is destined to increase. So how does that
Sure.
mean? So
Of the
how does
whole
that
system,
mean?
eventually, maybe.
Yes,
That
y'all
doesn't mean
agree.
right now. But that
Okay,
doesn't mean right now.
Yeah.
But hear me out. Since y'all agree that that is destined to happen, then it is destined in evolution for simple organisms to not be able to
No.
become. How
So,
not?
okay, if I'm destined to die, does that mean that I'm dead right now?
No. So right now,
So,
so how?
if it is destined to be the case that entropy will increase in 1 billion years, does that mean that entropy has increased for the last 4 billion years?
No.
So there you go.
I'm trying to come up. I can come up with an example. I feel like for if you die, then you're not. If you're destined to die, that doesn't mean you're dying right now. And then compare
Okay,
that
so
to
if
the
you're
evolution.
destined to increase entropy, that doesn't mean you're increasing entropy right now.
But it means you're eventually increasing entropy, which means that
Yeah, in
you're
4 billion years, sure.
eventually turning complex organisms to simple organisms.
Yes, Earth is going to die.
So how is evolution accurate
Well, hold
for?
on. We're not going to turn complex organisms into simple organisms. There are
Yeah,
just
that
going to
doesn't
be
make
no
any
more
sense.
organisms alive.
As long as
Which turns them to simple.
there's energy available, then complexity can continue to occur.
But it doesn't get better.
What do you mean?
Sure,
If it's
again.
destined to get worse, then
It's only destined to
evolution
get worse
can't
in the
get
far,
better.
far future. In the far future, after like more than 5 billion years from now.
It doesn't matter. It's destined. It's destined to get worse. Both is destined
Hold
to
on,
get worse.
I'm gonna draw a graph for you.
Okay. This is crazy though. I hate to argue with someone with a PhD, but this is my belief, so I'm gonna have to hold strong until I'm proven completely wrong. Like,
All right, here's a picture.
like no source at all, like barely tells me anything that is in favor of what I'm saying.
All right, ignore what else you see. Also ignore the smudges on the piece of paper.
That's fine.
I'm gonna
Peterson,
make it bigger. Hold on.
Yeah, please.
Apparently, you can actually make me like even bigger.
Yeah, I can
Yeah.
pin you. How do you do that? I'll try to figure it out.
Blitz as my physics professor right now. Wow.
You're not the only one.
I am only a sophomore, a pre-med student in college.
That's fine. You're
So
fine. Okay.
Oh, what the heck?
This is fine. So ignore what's going on up here. That's from a meeting last night. Um, so let's say that this is a graph of the entropy of the Earth over time. This is
okay,
now. This is 5 billion years from now.
all right,
What we're saying is that the entropy could go something like this. It's decreasing
over
for a
time.
really long time, and
Mhm.
then in 5 billion years, it starts skyrocketing. That could totally happen. And so during this
How?
entire time when it's decreasing, you can have evolution where you have increasing complexity, you have more evolution, and so on and so forth. It's only at this point that you would expect to see things to start to change. That's all.
But it's basically what I try to say from that is that as entropy is increasing over time, simple organisms are not able to become more complex over time, or
So,
that's
That's not.
but entropy
inconsistent.
isn't. But entropy isn't increasing. It's decreasing right now.
Oh, you're saying it's decreasing right now?
Yeah. So this is entropy here, like now, and the
Okay.
entropy is going down as time proceeds.
Yeah.
And then once our sun dies in 5 billion years, then we won't have a source of energy to decrease our entropy. So the Earth will effectively become a closed system. At which point the entropy will start to increase.
And then evolution is not
Yeah, then
actually.
evolution is done. But that's of course it's done. All life on Earth is done.
Well, not
Um,
not really.
well,
But
how do you make a
we could have life
conclusion?
around hydrothermal vents for
No. But in 5 billion years,
extremely
the
long
sun is
times.
going to engulf the Earth.
Yeah,
Yeah.
All life on Earth
probably.
is done.
Okay, Blitz, how do you say that, like, how can you make a huge claim that entropy is decreasing 100% other than instead of half and half over time right now?
Entropy it's a statistical process, so it's not going to be it's not going to like oscillate between two things.
Not half and half, but you know what I mean. I mean, like,
Well,
how is it going to?
how do we know? Because energy is being added to the system,
No,
and that
no, no, no,
energy is
no.
being
I
used
asked,
and converted to useful energy.
I asked, how is it going to? How is it going to decrease over time right now, since the Earth is it's a
Right,
closed
right.
system?
Because we can see we can see what's happening to the Earth. The Earth is receiving energy from the sun. That energy is being converted by plants into useful work, or into energy that can be used for work, into useful energy.
Basically,
So
what I'm saying,
just the process of photosynthesis decreases the entropy of the system.
whatever you're saying about entropy in the universe decreasing is still inconsistent with evolution, and I'm going to tell you why. It's because whenever you say entropy increases, whenever you take that pot off the stove, in that pot, you're saying that some places in the universe it's increasing, some it's decreasing. In order for it to completely match up with evolution, it would have to always be decreasing right now everywhere.
Why?
No.
Because all simple
The sun's
organisms turn into
the sun,
complex organisms
there
in
are
evolution.
no organisms on the sun.
No, I'm talking about on Earth. Like I'm using what you're saying.
So if you take the total entropy of the Earth, it is decreasing right now.
But you can't just take the total energy. You can't take that because you're saying I can't take the entropy of the universe and say it's going to increase over time, like for
So
everything.
you're right,
So
but
you can't just make a claim that, oh,
you're
it's just
that's fair.
because.
So
You're
we can
again
just
doing the thing where you say that, like, we take the idea that entropy must increase over time, with you're equating that with entropy for all things must always increase, always at all times. And
No,
that's
I'm
that's
saying
not
it's
true at all.
destined to increase
If
for
we
everything.
Yeah, so what? If I throw a ball up in the air, it will come to the ground, but that doesn't mean that it can't go up into the air at some point. Now, if we say that entropy can decrease in one system while increasing in another system, does that mean that in both systems it does that for eternity? No, eventually they meet back in the middle, I guess we could say. But
Basically, I'm using what Blitz has told me. I'm no longer using my interpretation of entropy of the universe, meaning that it increases in the sun and it increases in the earth. I'm using Blitz, and what he's saying is
so
that
all we
it
know.
decreases. You're saying it, well, just please correct me. You're saying that it decreases right now entropy is decreasing in the Earth?
All we know is that the entropy of the Earth doesn't have to increase, right?
Yes, it
The
does.
second law of thermodynamics doesn't. No, it doesn't.
No, because energy from the
Right
sun
now,
arrives on Earth.
yeah, right
That
now,
pot
the
that
Earth
you
is
take
not
off
a
the
closed
stove,
system.
it has to have places in the Earth where it increases.
No, I'm talking about the total
The
entropy of the Earth.
ramen is the Earth in that
It doesn't matter
analogy.
about total entropy. We can't pick and choose.
No, Aiden. I'm talking about the total entropy of the Earth, and all we know
Is that it's
is that
decreasing.
the total entropy of the Earth doesn't have to increase right now. We don't know whether it's increasing or decreasing. It could be either. Now we have to go look at what's actually happening and see if we can deduce what's happening, right?
And you're saying the net entropy of
The
the
net,
Earth is
right.
decreasing.
Right.
But what I am arguing and what I'm trying to say is that just because it's the net entropy does not mean it isn't increasing everywhere in the
Right.
Earth.
Yeah. It's not decreasing everywhere on Earth, of course.
In order
but
for
it
it
is
to be
decreasing in
consistent,
some places.
in order for it to be consistent with evolution, it would have to be totally decreasing, like the
Why?
universe is
Why?
totally increasing. Because
So,
simple
let's
organisms, because in evolution, simple organisms are all turning into complex organisms.
No. That's not true. There are plenty of simple organisms that are just dying. And that's a decrease in, or that's an
Then
increase
that's
in entropy.
inconsistent with the evolution theory too.
The
Wait a
fact that
minute.
organisms die?
Death?
Yeah.
That's how evolution works.
No, that's inconsistent.
No,
Both-
it's
no,
not
consistent.
even remotely
Death
close.
has to happen for evolution to work, because otherwise you wouldn't have competition.
Hmm?
If organisms
dying-
didn't die, then new organisms would
Blitz.
never exist. Therefore, evolution could not possibly occur.
For what? If what?
If organisms never died, then organisms could never change because there would never be any new organisms.
I'm not saying they
Well,
don't die.
there'd never be like a niche for new organisms to take.
I'm not saying they don't die. I'm saying they go
That's a
from.
deep-
I'm saying in evolution, it's saying that organisms go from simple to complex, right?
Yep.
That
Well,
has
some
nothing
do,
to do
and
with them
some don't.
dying.
No. Some organisms become more complex. Some organisms die off.
What? Where does it say that at? Let me do some research.
You're
That's how
pretending that the
natural
living
selection
organisms themselves are the only system that exists in the universe, and that's completely wrong.
So the way natural selection works is that let's say you have a population, and half of your population has a beneficial mutation, and the other half doesn't have a beneficial mutation. When that happens, the ones with the beneficial mutation will outcompete the ones without the beneficial mutation. So the ones that got outcompeted will die, and the ones that succeeded will produce more offspring and fill in the evolutionary niche of the ones that died off.
Okay,
So death
and what would you say?
Death is an inherent part of evolution.
And what would you say about mutation? Would you say that they are disorderly or orderly? The mutation
What do you
for
mean?
so
They're
basically,
neither.
well, hold on. Let me finish the question. If organisms are going from simple to complex, those mutations to make them happen, what are they, orderly or are they disorderly?
They're neither.
Most mutations are bad and end up hurting the organism, but some don't.
Mutations would have to be orderly in order for us to improve from disorderly.
Not all of them. The mutations that happen to organisms that end up with negative mutations, those ones end up dying off.
What is an orderly mutation? What does that mean?
He's talking about a mutation that gives more complex structure.
Mm-hmm. And basically, I'm saying that they would have to be orderly in order for us to improve from disorderly. What did you say to that, Blitz? I didn't hear.
Sorry, my mouth is full. 1 second.
That's fine. And I say that because the beneficial mutations.
Okay, so we agree that mutations can happen. Let's say, I hope we agree that. Let's say we have a population that's right now homogeneous. The next generation.
What does that mean?
It's all the same, all identical, right?
Okay. Oh, you said homogeneous. Okay, I'm sorry. That was so dumb.
So the next generation, all of these organisms, they give birth to the next set of organisms, right? Next generation. Half of them have a positive mutation. Half of them have a negative mutation.
Okay.
That's not negative mutations are more likely, but let's just say for a moment it's half and half, right? It's not
Yeah.
that. Actually, let's even say that it's 3/4 negative and 1/4 positive. So more matches up with reality, right?
Yeah.
It's not that all of these mutations have to be positive. It's that the ones with negative mutations are going to die out, and the ones with positive mutations will survive more easily and fill in the role of the ones that had negative mutations but died out.
So then
So
basically,
it looks as if only positive mutations accumulate, but that's because all of the negative mutations cause death and cause those populations that have those mutations to die out.
that's still inconsistent. So basically, you're saying positive mutations would be orderly and match the law of or entropy would match entropy, but
No, no, no.
negative
This has nothing to
mutations
do with
would
entropy.
not
This is
match
just
entropy.
statistics. This is just statistics. This has nothing to do with entropy at this point.
It really does.
It does
No, because we're
not.
talking about
Introducing
microstates.
entropy here makes no sense.
Entropy is about macrostates. It's about a system as a whole. We're talking about individuals. This is like individual
Oh,
atoms of
individuals?
gas, right? Like you don't talk about the entropy of a molecule of gas. You talk about the entropy of a whole box filled with gas. Similarly, you talk about the
You
entropy
just
of a
taught
whole
me something.
system.
Can you say that again?
Yeah. You don't talk about the entropy of a single molecule in a gas. You talk about the entropy of a box full of gas. Similarly, you don't talk about the entropy of a single individual in a population. You talk about the entropy of a whole population of people or whatever. Entropy is only defined as a macroscopic quantity that describes a whole system, rather than as a quantity that describes individual pieces of a system. Now, there is a sense in which you can break up entropy, or you can break up a system into subsystems. So for a person, you can talk about the entropy of a person, because a person is made up of a whole bunch of different stuff, right? But like we can fine grain these things away, and we can just talk about, as far as like individual mutations go, we can talk about statistics of those mutations, or the entropy of the collection of mutations.
So Aiden,
Why did
if we take if we take a culture of bacteria and we treat it with penicillin or whatever, the vast majority of those bacteria will die. Why is it that some of them don't?
I don't know.
Because
They're better. They fight stronger, I guess. I don't know.
What allows them to do that?
Just tell me.
It's different genetic compositions that they have. So
Okay.
the mutations are exactly the thing that allows for organisms to differentiate and then be adaptable in future environments and go on to survive.
Well, saying
So the idea that evolution can't make this happen is like literally the opposite of what the observed phenomenon are.
so was the sun in existence before the Earth blitz?
Probably a little bit before the Earth, or at least before the Earth was in its current state, yes.
The solar system
Let me-
overall formed at pretty much the same time.
Sun
Yeah.
formed.
The
Earth
sun
was
probably achieved nuclear ignition before there was before Earth as we know it today, like a single object with a single satellite orbiting this particular pocket. The sun probably achieved ignition in its core before that happened, but the overall it forms at the same time. What? Hello? I can't hear anything. Oh, something happened. All right, he's right here. It's just a weird connection thing.
My Wi-Fi glitched out. I'm sorry. I was gonna say, I just don't understand why every single source that I like search up about like entropy and evolution, it states that evolution is a decrease of entropy.
Because they don't believe in evolution. That's why they say those kinds of things.
These are like physics.gmu.edu.
Can you like just like point me towards a source, something that I can Google to find the same thing that you found, so I can take a look at?
And then I'll let you. Yeah, and then I'll let you control F it. Physics.gmu.edu.
And then what's the
Okay, dash. Ooh, this is gonna be. How do I say
how
that?
did you get there? Did you
Can't
Google?
send links.
Okay. I googled why would entropy not be consistent with evolution?
Why would entropy not what?
Not be consistent with evolution.
Okay. Does life on Earth violate the second law of thermodynamics? Is that what you're talking about? Or are you
Basically,
talking about?
it boils down to me
Well,
wanting to figure out.
what's the name of the website? Is it like entropy in microscopic states? Does life on Earth violate the second? Like, is it a green website or is it a website with a green background?
Just whatever you find that says entropy.
I
Entropy
found the
goes
GMU
against.
one.
I found a
Yeah.
few GMU ones, but I can't find the ones specifically.
It says physics.gmu.edu.
And then what's the rest? Is it like a tilde and then a roritor?
Yeah.
Yeah,
That's
I'm
why I
looking
didn't know
at
how
it
to
too.
pronounce. I didn't know what to say.
Yeah, it's a tilde.
Just if you could translate that and
Yeah. So which part are you particularly looking at that bothers you?
evolution is evolution. The argument goes is a decrease of entropy because it involves things getting more organized over time, while the second law states that or says that things get more disordered over time.
So evolution violates the second law. Did you read the next sentence?
I did not. I'm just going off of what does it say?
Okay, the next sentence says there are many things wrong with this argument, and it has been discussed ad infinitum.
Infant what?
It's been discussed forever. But the next sentence literally says there are many things wrong with this argument.
It doesn't say like what is wrong with it. Could we go to a different source?
It does.
No,
Yeah,
yeah,
it says
it does.
both.
And then actually a couple
It does.
sentences later, it says, this is unfortunate since a very simple calculation shows that it is physically impossible for evolution to violate the second law of thermodynamics.
Yeah, that would be logical. Yeah, that would be logical, or like you said, nothing would exist.
No,
It says,
It
Scientific.
says it's impossible for evolution to violate the second law of thermodynamics. You say it does. Your source says it's impossible
That's
for
not the
evolution
source
to
I've
violate
been using. That's just what I looked up. The source I've been using is rcg.org-books. Do you want me to tell you it?
yeah, why not?
RCG stands for the Restored Church of God.
Yeah. And that's the source I've been using, and I want y'all to disprove it.
Well, you should use a scientific source.
Is it? Are you on?
Even my scientific sources. Okay, I'll tell you a scientific source.
You did,
AllaboutScience.org.
and it did not support you.
AllaboutScience.org-second law of thermodynamics is the main one that I use. I just looked that one up because I was trying to ask a certain question.
AllaboutScience.org/second law of thermodynamics.
Yes.
It
All
says
About
not.
Science is not a scientific organization.
What is it?
Their address, here's their contact us information. All About God Ministries Incorporated.
Oh, yeah, they're not a science website.
Oh, I didn't know that. I just was looking for
Now you do.
science. Yeah, I do. Okay,
But
so
let's take a look at this and see if there's anything wrong with it. This All About
yeah,
Science.
that's what I really want to figure out.
Yeah.
This apparently these are the sources that are popping up for me.
Okay, let's look at. I'm just scanning through it to see if I can see anything that's
Second law of
wrong.
thermodynamics, increase entropy. Please look at that.
Yeah.
Part of it. And then second law of thermodynamics in the beginning.
Yeah, this is not a good understanding of the first and second laws.
What does it say?
It says while quantity remains the same, first law, which is referring to like energy remains the same, the quality of matter energy deteriorates gradually over time. But that's not true. Entropy is not a measure of disorder. It's often a measure of disorder, but it's not. It's not like it's not like things get worse. It's not like the quality of matter decreases. That's not what it means. That's not what entropy is. Would you say that?
Well, why is that? Whenever you look up the definition, you go to dictionary.com.
Because they simplify things for lay people. But would you say, for example, that if you roll 2 dice and you get a 2 and a 6, that has more quality than if you got a 2 and a 5?
Um, yeah, 2 and a 6 would be more quality than a 2 and a 5.
Okay, how about what if you got a 2 and a 2 and a 3? Would that be more quality than a 2 and a 5?
That would be less.
Because according to this, 2 and a 5 is the least quality of all of the ones that I just gave you, because it has the most entropy.
The most entropy means the least quality. Yeah, but that's what
No,
the
no,
whole
but that's
measure
not
of.
true. Rolling a 7 is not less quality than rolling a 6 or rolling an 8.
Yeah, with dice. But what about with science? What scientific
Wait a minute, that's what entropy
example
is.
can you
Entropy is
give?
a statistical measure.
What example in science could you give me for like explaining
Wait a
how
minute, statistics is an empirical science.
how is entropy statistics?
Entropy is a measure of number of microstates that correspond to a macrostate. That is literally statistics. It's literally counting. The
Where does it
definition of
say that
entropy,
definition at?
it's the definition of entropy is the number of
Oh,
microstates that correspond to a
that's the
certain number of
formula.
macrostates.
That's the
Sorry?
formula. That's the
Yeah,
formula.
that's what entropy is.
Yeah, laws have formulas.
Yeah, and so I just gave you an example using that formula, using dice.
Isn't Hold on. Let me ask you the second law of thermodynamics. Look, let me tell you this definition. Just tell me if this is wrong. The definition I have is that the second law of thermodynamics states the state of entropy of the entire universe as an isolated system will always increase over time.
Yeah, that's a formulation of the second law that's valid. Yes, assuming that the universe is an isolated system.
Well, why is Kim Libretex teaching that?
Well, because it's a fine definition.
Then, that's part of the law, though. So why is that not? Why
Which
would they use
which is
that as
part
the
of the
main
law? The universe part?
entropy?
Entropy is part of the law. Yeah, the second law of thermodynamics
It's
is
the
about
main
entropy.
part of the law.
Yeah, but then you have to go ask, what is entropy?
Why would we assume? Why would we assume the universe is an isolated system if in
Because
science
the
there's no
universe,
God?
because the energy of our universe is decreasing.
But that doesn't have anything to do with an
Yeah, it
isolated
does.
system, right?
So an isolated system is a system that has conserved energy. If our universe does not have conserved energy, it's not
Why
by
did
definition an isolated system.
Why would Khan Academy, I think it is, give me the definition of isolated system is a system that does not interact with its surroundings?
Because that's usually what's required in order to have non-conserved energy.
Okay, so then why would that not be? Is Khan Academy not a credible source?
It's a credible source, it's just not a very advanced one.
It's targeted for middle school and high school students.
Yeah, you don't need to make if that's the simple version of it and that's what it is, then that's
Well, no,
good.
it's that statement applies in most cases, but the universe is not most cases.
Yeah, the only other way that the universe could not be an isolated system is if there is a God.
Not necessarily. It could just be a thing
What
that
else
has
is putting
energy
energy
leaking out.
into it? What else
No,
can
no,
put
it's
energy into
well.
the universe?
First of all, the
You'd
energy.
have to
First
establish
of all,
that a God exists, and that evidence does not exist.
And I know
also,
that it doesn't.
also,
I
You
energy
know.
have
can
an
be out of
argument
the
from
system.
incredulity here. You're saying this is what we know, and we're missing something, therefore it has to be God.
No, basically what I'm
That's an
saying is
argument
that the
from
universe.
incredulity.
Also, the universe isn't gaining energy; it's losing energy.
Yeah,
So you don't need a system for it. Energy is leaking out,
this
or
is
rather,
what
energy is just
basically.
not conserved at all.
Whenever I put the definition into it, this is what it's saying. It's saying the universe does not interact with anything surrounding outside of it. Therefore, it's not putting
Yes,
energy
they're
into the
giving you
universe,
an
meaning that
unsophisticated
it's
view of a
losing
closed
energy.
system. They're
It's
giving you an
losing energy.
unsophisticated view of a closed system. And we can
That's
go into even more detail if you want. Like, the notion of energy is not even well defined on a universal scale. So like that's a whole separate issue. And closed systems by definition can't be infinite, and our universe probably is. So that's a whole
what can
separate
you
issue.
argue? What can you argue about energy not being whatever you said it's not.
well defined in a closed system, or like in our universe. Yeah, on a global scale. Yeah, the idea is that energy depends on inertial frame what inertial frame you're in, and because of relativity, Einstein's relativity, there is no preferred frame by which you measure energy. So it's like just not a
But
well-defined.
it doesn't matter. That explains literally how the Earth was formed in science, right? The work,
Well,
energy
we
is
don't
needed to
consider
do the
the
work.
whole universe when we think about Earth formation and the evolution of the solar system. We consider like the local area around the Earth, like maybe the galaxy or maybe the galaxy cluster.
Basically, I would say like, wouldn't the contents of the universe that make up the universe, uh, wouldn't that be the universe?
Well, I mean, the universe is the whole thing, right?
Yeah, of all those contents.
Well,
So without the
yeah.
contents, there's no universe.
Well, that's not
So how
necessarily
come you
true.
can't?
I can
How
imagine
come
an empty universe.
if it's an empty universe, then how would it have energy?
I mean, who's to say it would?
Okay, just the point of this is comparing what I'm saying to our universe that has everything. In this case, wouldn't without the contents of the universe, there would be no universe, right? Because
I
that's
mean,
what the universe is those contents.
yeah, no, I don't. I
Uh,
don't think we
it
agree.
it could be space, but not filled with matter.
So you're saying that the Earth and the Sun and the stars that are a part of the universe are not the universe.
They're part of the universe. They're not the whole thing.
But if you consider every single thing, they are not the universe.
Is
Yeah,
space
we're
a
just talking
thing?
about imagining a different kind of universe existing.
Would you consider space a
I'm not
thing?
worried about space a thing.
Yeah.
I don't know what I would consider space as. That's
So
not what
if
I'm
you
trying to
if you
talk about.
remove the stars and the planets and the gases, but you leave space, then I would say it's still a universe.
Can space exist without everything else?
I don't see why not. It doesn't seem like it's
Space.
dependent on other stuff being there.
There very much appears to be space between the objects. So yeah,
Okay, so whenever I looked it up, it does say space and space-time can and do not exist apart from the matter and energy that creates the gravitational field.
in
Well,
this
wait a minute. No,
universe,
no.
yeah,
So you're talking about space-time not being able to work in the absence of matter. That's true, but space-time can still exist. It would just be flat and uninteresting.
It says it can and do not exist.
Okay, what source are you looking at?
Einstein.stanford.edu.
And it says that space-time cannot exist absent matter.
That does not look like a credible source. Let me look at it. What is wrong with these sources? Oh my gosh. Physics forums, is that a credible source?
Physics forums is usually
No.
pretty good. Yeah, it's
But
usually pretty good.
it looks like a whole bunch of people answering each
Yeah,
other.
it is. It is. But the people on there are
those
actually
forums
qualified.
is.
Like just as somebody who's used physics forums a lot and can like corroborate a lot of their statements, like it's usually pretty good.
So what is space without nothing?
Well, it's just space there. It's space, and it's just doing nothing. But like it's still space. Like there's still location.
If it's doing nothing, then is it nothing?
Okay, I'm currently doing nothing. I'm just sitting on my phone talking to a bunch of
There's
Mac people.
energy, there's gravitational energy potential, gravitational potential energy, all that. Nothing's not doing nothing right now.
Okay, so I can give okay, here's the thing though. In general relativity, we do things we do this thing where we talk about like vacuum states to the Einstein solution, to the Einstein equations.
Okay.
Einstein equations are what describe spacetime. And a
Okay.
vacuum solution is a solution to Einstein's equations that doesn't have anything in it. But we can still
Okay.
describe these spacetimes, and they can still be interesting spacetimes. They could have gravitational waves in them, which isn't matter. It's not matter, it's not light, it's just spacetime doing spacetime things. You
Like
can
what?
describe what do you mean? Like what? It could be waving, it can be oscillating.
It could be what?
Oscillating.
What does that mean?
Gravitational waves are like think of light waves, except in space-time rather than light.
Okay, light waves or
So,
something for sure.
yeah, but gravitational waves are not quote unquote something. They're just space-time doing space-time things. They don't need anything.
Gravitational gravity is energy. Energy is something.
Gravi- Gravity is, well, no, gravity isn't energy. Gravity has energy.
Or has energy. So
But
if gravity has energy, then
gravity
that
is
is
just
something.
the curvature of space-time. So would you say, so in the absence of curvature of space-time, then you just have flat space-time, which is boring, but it's still there. It still can
I'm
exist in the
saying
absence of other
I'm
stuff.
saying if no activities are happening and it's
Then you just
just
have flat,
there.
boring space-time. So that's fine. You can have it like, it is possible that a universe could exist that's just empty, and it just has flat, boring space-time in it.
But it's not possible for this universe to be like
Yeah,
that.
well, this universe has stuff, so of course it can't not have stuff.
Basically, my point is that like basically my main question is just that is how can like is the basically it's is the earth and the sun and every single thing in a universe the universe?
The universe is.
You might say that if you included the word space-time in that description.
Space-time?
Yep.
I'm saying everything. It doesn't matter. All the laws,
Okay, yeah, if you
whatever.
include space-time in there, yeah, the universe is the space-time and everything that lives in it. That is that is the universe, yes.
Yeah, the
Okay,
universe
so
is.
then what is the universe without
It's
then
nothing.
what
It has no properties.
okay. So then how why can't you apply entropy increasing to everything?
Well, you can apply it to the whole system. You can't apply it to the individual pieces of the system.
But all of that together makes up the whole, and what I'm trying to say is that it increases for every single thing in the universe.
Okay, here's some basic math. Is it true that 3 is a positive number?
Yeah.
Okay, is it true that 5 plus negative 2 is a positive number?
If what?
5 plus negative 2.
Yeah.
Okay, but is it true that 5 is positive and negative 2 is positive?
No.
Right, that's exactly what's happening in our universe. Our universe is 3. Its entropy is increasing. And there are parts of our universe where the entropy is increasing faster, and there are parts of the universe where entropy is decreasing, like the negative 2. Entropy increases and decreases in different places so long as the net is positive.
If I were going to try to describe like the temperature of the air in this room, we would use a measurement. It's 73.4 degrees.
What are these freedom units?
It is. Hold on, if I push the communist button on
It's
the
like
back,
22.
it tells me it's 23
Is
degrees.
that what the C stands for?
The C stands for communism. Yes,
I gotta use that
communism
on
unit.
Maria. That's hilarious. That's
So, anyways,
funny. She gets so mad when I tell her that Fahrenheit's better.
that's funny. But anyways, so that temperature describes, the average heat energy of the system. I think that's generally how I talk about it. Or is it average or total?
Which one? What it describes what?
Is temperature the average heat system or the total heat energy of the system?
It's neither because it's the average kinetic energy of the
Right.
system.
What does temperature have to do with what?
I'll get to the point here in a second. So,
Okay.
anyways, that is the average temperature. But the heat energies of the molecules in this room are not all the same. Okay. It's not the case that every single molecule of air in this room has the exact same amount of kinetic energy. It's just that the aggregate of it gives us that temperature reading. There are some molecules in this room right here that if every single molecule had that amount of kinetic energy, it would be 1,000,000 degrees in this room. There are
In
some
fact, this is how
molecules.
boiling happens.
Yeah. Yeah, there are some molecules in this room where if every single molecule had that amount of heat energy, it would be very close to absolute zero in this room, right? So like with the entropy thing, the system is composed of many different parts all at different states. That's how we could describe the individual molecules and describe their heat energy in this room. But so you cannot just take the aggregate or the average or whatever and apply it to every single thing. You can't go general, like the specifics are not homogeneous to the general, right?
Okay, so
I don't
then
know if that phrase made any sense, but the molecules in this room do not have all exactly the same energy, right? And with entropy, it can increase, or did I say energy? With entropy, it can increase over time, but that doesn't mean that every single thing is uniformly doing the exact same thing. Like we've said that so many times, but I feel like we keep having to come back to it.
but if but if entropy is so if all uh, if simple organisms turn into not all, if not all simple organisms turn into complex organisms, uh,
Then that
to
just means that entropy is increasing somewhere else. It's not increasing within the biological organisms. Let's just
and
say that every single one of them is doing that. Then it means that it's entropy is increasing somewhere else.
okay, so let's say it's increasing somewhere else.
Yep, it is.
What
It
part of
is.
science describes why it's increasing somewhere else? What's picking and choosing to make it increase somewhere else? Why is it doing that?
Nothing is
When
picking and
energy
Why is
choosing.
it
The
doing
flows,
laws of
that?
physics just
wh-
operate.
Why would it
when energy
sometimes why would it sometimes increase
when energy
on
flows,
that?
when you have work in the form of light energy can do work. When you have work that flows from one object to the other, like from the sun to the earth, the system that gets the work can and does often have its entropy decrease, whereas the system that sends the work will have its entropy increase.
But what I'm saying is like why would entropy increase for like some organisms
Because
but
Earth is
not
receiving more
all?
usable work.
Yeah, the
For
Earth is being
why for some
bombarded with
organisms but
huge
not
amounts
all.
of
But
low entropy energy.
why is
Like
it going
when you eat food, when your body breaks down that food, the vast majority of all of the energy in there is lost as heat.
okay, but that still doesn't explain why it's going here. It's increasing for these organisms, but it's not increasing for these organisms to allow them to become more complex. It's not explaining
Well,
why it
because
can't.
so this is just statistics now. You have a system whose entropy is decreasing, the Earth.
Okay.
And so if all else is equal, some of those like because we're talking about averages here, if all else is equal, some of those systems, subsystems of the Earth, like individual organisms, will decrease the energy, and some of them will increase their entropy.
Okay.
And so you will have systems that decrease their entropy just by statistics. And this is why it takes a long time, by the way. This is why evolution
But
takes so
what
long.
is the science that describes
This isn't a
where it's
scientific phenomenon.
choosing to go?
There's no
Science is not going
choice
to predict
taking
where.
place.
Science is not going to describe where or who or what. It's just going to say statistically it will happen.
But science, you can see where things happen sometimes in science, right?
If you fine grain your observations, then yeah, you can probably come up with an explanation as to why it happened here rather than here. Like maybe it happened, maybe evolution was happening in like this boiling water or like this undersea trench or whatever because there was a bigger source of energy there, and it didn't happen in like the Arctic because there wasn't a big source. Like you can fine grain your observations to make more accurate predictions, but it doesn't matter so long as we're talking about averages, which we are. It is not unreasonable to expect that some would have increasing entropy and some would have decreasing entropy.
That makes sense, but there's no reasoning behind like why it's happening
We don't need a
here and
reason.
not happening here.
Think, so we could come up with reasons if we start examining certain phenomena specifically, but we don't need a reason when we can just say, well, things occur randomly on Earth, and so By random chance. Some systems will have an increase in entropy, and some systems will have a decrease in entropy.
By chance?
So by random chance, yeah, because the Earth is it's always reshuffling itself, right? Like, water's evaporating, then water's raining in somewhere else, and then there's lightning, and then there's just random shit happening all over the Earth all the time.
So by chance.
Yes, literally by chance. Like the question of why did entropy increase? Why did life form? In like next to this rock instead of next to that rock. That's completely random. Like you could, or rather, it's random as far as is important. Like you could probably come up with an explanation, like, oh, over time there was like a westerly wind that blew more nutrients into this side of the rock or whatever. But at the end of the day, like it doesn't matter. Like it's effectively random.
Okay, well, I have a source to
Earth
talk
has
about chance.
Earth has a average temperature. In some parts of Earth, it's hotter than that. In other parts of Earth, it's colder than that. So it's as if you're asking, why does the energy decide to flow in one direction and then retreat from in another direction? There's no why there. There's no agency or anything.
Look deep enough
behind it. There are causes behind it that we can describe, but calling it a why is like implying that there has to be reason behind it, and by reason we mean like conscious agency or something. Like what is making the energy go more towards the
causality is how.
Yeah.
It's how?
It's how, not why.
What's the cause? Why did this happen?
No, how did this happen?
Yeah. There can be a reason things happen, but there don't have to be reasons why things happen.
So then, basically I'm asking how. I don't know why.
How is a hard question to answer. It doesn't mean that there isn't a how. It just means it's hard. Like, for example, it's really hard to predict the weather, right? Like we can only get accurate predictions about 10 days out, and beyond that, it's really hard.
Yeah.
And that's because
you said by chance.
Well, so I said by chance because just like how predicting the weather more than 10 days out, you're just as likely to get an accurate, like you may as well just flip a coin if it's going to rain or not 10 days from now. It's effectively by chance. It's not actually by chance, but it's effectively by chance because being able to do those computations, to make those predictions, is so absurdly complicated that with our given tools, we just don't. It is indistinguishable from random probability.
Okay, let's see what other, you're a doctor, right?
I am. Well, I'm a PhD. I'm not a medical doctor.
Well, yeah, let's see what other PhD professors say about chance. So, Dr. Harold Murowitz, professor of molecular chemistry
yes, a fellow
at Yale University.
He's Jewish too.
Has concluded that the odds of life creating itself by chance are 1 in 10, followed by 1 billion zeros. So look up his name and what he concludes about chance. It didn't
create itself by chance. Life is a self-replicating chemical system that requires energy and resources from the environment.
So I can't find this quote. Can you tell me what the website is that you're reading this on?
How Did the Universe Begin by Ralph Emerson. Hold on, let me just go to his name.
Ralph Emerson. You said Harold Morowitz earlier.
Yes, he's basically this site quotes doctors, but let me go see. Let me go look for a better source that's actually with his name. Dr. Harold. What do you know about Dr. Harold?
I know nothing about him. I just know he's Jewish.
On chance.
So, Morowitz. These are Morowitz's views. He was a vigorous proponent of the view that life on Earth emerged deterministically from the laws of chemistry and physics.
Here is the source. On the right side.word.press.
On the right side.
Sound like an activist website.
It just says what he says about chance. Let me look for another one. All you have to do is just
it's on the right side dot what?
.wordpress.com, and there's also allaboutthejourney.org. There's also
Why can I not
jeffhester.com.
find these websites?
On the right side with George Kaler, a hard-hitting slice of conservative
I see it.
thinking.
No. Just look up Dr. Harold Merowitz, like I told y'all.
I did, and I read for you his idea of this. He was a vigorous proponent of the view that life on Earth emerged deterministically from the laws of chemistry and physics, and so believed it highly probable that life exists widely in the universe. So if somebody else, I'm almost done. If somebody else cites Morowitz and says, "Oh, well, he said blah blah blah," these like statistical things, or therefore life could only have been rationally explained by miraculous events, then they are not representing Morowitz's views at all.
I'm looking at like 10 different sources that.
But we're just looking at why don't we just look at quotes? Why don't we just look at quotes by the guy?
Search up Dr. Harold.
I'm looking at quotes. No, I'm looking at quotes from Dr. Harold Morowitz, right? Like we're looking at quotes. Right?
I want y'all to see what he says about chance specifically.
I know what he said about chance. He said that the probability of a simple cell forming by chance is 10 to the 340 million.
Yeah,
but
that's all I need to say.
No. Don't do that. Don't do the thing where you just read a quote until it agrees with you and then stop reading.
What else does it say?
The ultimate emergence of metabolism seems embedded in the laws of chemistry. In this realm, novelty piles upon novelty, and we change from the rules of systems of physical chemistry to those allowable rules of biology. With the emergence of distinguishable competitive protocols, the world becomes Darwinian, and we move from the domain of relative simplicity to the kind of complexity that eventually leads towards the emergence of mind.
So we go to biology. Basically, he's saying now we turn to biology.
No, what he's saying is that what he's saying is that cells it wasn't just no cells and then all of a sudden cells. He's saying that it was built upon step by step, deterministically, following the laws of chemistry.
And again, you quote mining from this guy and then saying, therefore, the idea of evolution is impossible, and it makes way more sense that life exists because of supernatural intervention or miracles or whatever, is totally, that does not represent the views of the person you quote mined. So no, what he says does not support you because your views are not his views. So obviously what he said does not support your conclusions because his conclusions are completely different.
That's not what I'm saying. I just quoted something that talked about him talking about chance. Just the statistic he gave is all I was wanting to talk about.
You think that it's impossible that life could have spontaneously evolved. He does not, but you cited him in support of your argument.
Where did he say it was possible? Where did he say it was possible at? That's all.
He was a vigorous proponent of the view that life on Earth emerged deterministically from the laws of chemistry and physics, and so believed it highly probable that life exists widely in the universe. That's the third
Blitz,
time.
Can you go back to the?
I closed out of it. I can go look for it again.
It's true that the odds of a complete cell spontaneously forming out of geochemical systems is improbably low, but
nobody's suggesting that that's what happened.
Nobody's suggesting that just voila, the first complex cells with hundreds of genes and all of the cellular machinery in place just all of a sudden appeared on Earth one day with no precedences.
Peterson, I've been on here for much longer than I should have because I have to work. So I'm going to take my leave.
Yeah.
Thanks for having me.
1:30 in the morning for me.
I had one last person though to quote.
All right, but I got to.
You got to leave before.
I can handle it. I'm a big boy. I dressed myself today.
So after I saw that quote, and as you heard in Blitz with what he said, with what he read, it included Dr. Harold talking about biology. I looked for the chance of biology happening by chance. So
What?
there's someone named Edward Conklin, and he's www.goodreads.com. Edward Conklin, Conklin.
Mm-hmm.
And there's a quote from him that says, and he's a biologist, and he says, the probability of life originating from accident or chance is comparable to the probability of an unabridged dictionary resulting from an explosion in a print shop.
Yeah, that's idiotic.
Which we can conclude that the universe originating by chance has no chance.
Did you say the universe?
Yeah.
The universe? What does the evolution of biological organisms have to do with the universe forming?
They happen in the universe.
Uh-huh.
So I'm saying there needs to be a how with law of causality.
No, there
has to be.
doesn't necessarily. Even if
That's what the law says.
even if there does, it certainly does not imply the Christian God. I have a
that
question.
alone does not. That
Earlier,
alone does not.
yeah, I have a question. Earlier, you said that the odds of a cell forming are 1 in whatever it is, a preposterously huge number. Okay, what are the odds of a miracle happening? Give me the number.
It didn't say odds of a cell. It said odds of life creating itself.
No, earlier you mentioned a cell, and you gave that huge number. Well, it's actually a tiny number because there's a huge number in the denominator. So
yeah.
if those are the odds,
1 in 10,
yeah. So anyways, if those are the
0.
odds of a cell just spontaneously forming or whatever, which isn't even how the idea of life emerging on this planet works at all. But let's just go with that number. What are the odds of a miracle happening? Because if it has to happen by the intervention of God, then what are the odds of that happening?
The same amount. The same level.
You've got to be kidding me.
Yeah, because overall, it's just stating that there's no chance. 0.000 billions, 0 billion, no.
Yeah, that's not zero.
110.
I got bad news for you. A 1 and then a very large number in the denominator does not equal 0.
Basically, I'm saying with what Dr. Harold said is that the number is 10 followed by 1 billion zeros, which is point.
A billion zeros? I don't think that's the number you
10 billion
cited earlier. Okay, let's just say that's what it is. What are the odds of a miracle taking place as the alternative explanation?
The same amount.
How do you arrive at that number?
Because in science, a miracle doesn't have chance. There's no chance for a miracle. It's not even
there we go. There's
science.
no chance for a miracle. The odds of a miracle taking place are 0. So any alternative explanation that has a statistical probability is therefore better.
But it
doesn't matter how tiny the number is. Any number larger than 0 is the better explanation. Do you know by what factor any number is larger than 0?
Okay, there's a law.
It's infinity. It's infinity. Infinity. No matter how small of a number you come up with, it is infinitely a better statistical value than 0.
You know what's crazy? I found a source saying that miracles are more possible or have a higher chance than what Dr. Harold said about that number.
So did you get it from JesusIsLordForever.science.com?
No.
Give me the source.
Law. Littlewood's Law. Just look up Littlewood's Law.
Littlewood's Law?
Mm-hmm. And read that number.
A person can expect to experience events with odds of 1 in a million at the rate of about 1 per month.
Referred to as a miracle is what it states in it.
Yeah, miracle, quote unquote, but a miracle is a literally supernatural event with a statistical probability of 0. admitted to by you earlier. This is a colloquial, this is just a casual use of the word miracle. If I won the lottery, I would say it's a miracle, but it's not a miracle because I bought the lottery ticket, I picked the numbers, and then the numbers were drawn. It was not a supernatural event.
It was a miracle that you won the lottery.
No, it's not a literal miracle because
Yes,
a miracle
Let's
is
look
an
at the definition.
unexplainable supernatural event. Statistically unlikely is not what a
It
miracle
is unexplainable.
It's absolutely explainable because I
It's
bought the
explainable
ticket,
how you
I
got
picked
it.
the numbers, and then the numbers were drawn.
Yeah, but the
No, there
number
are no
being
yeah
the
buts.
right
Yeah buts
one,
live in the forest. This is you being wrong.
it's a miracle is a highly improbable or
A
extraordinary
miracle
event.
is a supernatural, unexplainable phenomenon with a probability of 0. That's what a miracle is.
Have
A
you looked at the
probability of
definition?
0. The
Have you looked at the
probability
dictionary?
of a miracle is 0.
You keep saying the same thing, but I asked you if you
I
looked at the
keep telling you
dictionary.
what the definition of a literal miracle is, not the colloquial sense of, oh, it was a miracle that I fell off of a cliff but didn't die. Except, no,
Yeah,
you
because the
landed
chances
on a
of that is
pile
very,
of
very low.
mattresses. So it's actually completely understandable why you didn't die.
It's the chances of that is very, very low, and that's basically what a miracle says. The chances that you're going to draw the right number is very, 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 very low.
Yes, but it's not a supernatural event.
It doesn't say supernatural in miracle. One might say that it is supernatural
A
whenever they get a
surprising
miracle.
and welcome event that is not explicable by natural or scientific laws and is therefore considered to be the work of divine agency.
There's more definitions. You don't just have to say like, oh, it's just this.
So words can have more than one definition and there can be synonyms for things, but a word has to have a unique definition, and the uniqueness of a miracle, because I could just say coincidence. But if two words mean the same thing, then we have to just get rid of one of those words. There's no need for one of them. So miracle has a unique connotation here, which is the miracle event is a supernatural, unexplainable phenomenon.
Okay, but I mean that's the law. So, and it's saying that the chances of that law of the supernatural happening is a higher chance than what Dr.
No,
Harold said.
oh, now you're just a liar because it doesn't say anything about a supernatural event occurring. It just says the law. I looked this up just a little bit ago. The law says that you should expect an event that has a 1 in a million % chance of happening should happen to you about once a month, because there are an enormous number of things that happen to you, and so there are an enormous number of opportunities for any rare event to happen, but they're not supernatural events. They're just
Okay,
rare events.
So 1 in 30 million.
1 in a million.
1 in a million per month.
No.
30 days.
A single 1 in a million chance event should happen per month.
Okay,
That is
it
what
happens.
that is what that law is.
The implication of 10 followed by 10 followed by 1 billion zeros to the universe, life creating itself, is...
It didn't create itself. Nobody says that it created itself. And again, we've been over this. Doesn't matter how small the number is, it's still an infinitely more probable proposition than a miracle taking place, because a miracle, as admitted by you, has a statistical probability of 0. Thank you. And
I just have
good
one
night.
last thing.
No, you don't. I don't have any more things. I have been on this live for 2 hours and 50 minutes. It is 1:45 in the morning. And I just, that's all I got.